All right, thank you. I'm going to share my screen here. And can you see my slides there?
Yep.
All right. So thanks for the intro. Yeah, I'm Bryce. I'm a senior software engineer here at Hiro. Today I'm going to focus on Clarinet, which is kind of my main focus at Hiro, but then I'll briefly touch on some of the other things that Hiro offers as well. And being that this is a Clarity focused course, Clarinet is going to probably be a thing that you're going to be interacting with a lot if you haven't already yet. So let's just go ahead and jump right in. Okay. So this is kind of the outline. We can skip this page, but I'm going to start off with this intro. And basically, so Clarinet, and we also have this Clarity VS Code extension. So Clarinet is Hiro's go-to tool for basically everything. We're trying to provide everything that you need to write, test, integrate, and deploy your smart contracts. So in the ideal world, this is the one and only tool that you need to do everything that you want to do to write your smart contracts. And then the Clarity VS Code extension kind of works with Clarinet to provide, basically Clarinet talks to VS Code to give you all kinds of nice features inside of your editor, which I'm going to show some more details about that as we go. But those are the two big pieces that I work on here at Hiro, and they're going to be really helpful for building your contracts. So basically what I want to do is kind of step through some of the key features here, and then I'm going to jump into a demo. We're going to see these things actually in action. So starting off, if I'm starting a new project, I first use Clarinet to build my skeleton code. So it creates my directory structure, creates the files that I need. If I run Clarinet new billboard, here's the example, the name, then it generates the billboard directory and all of these files, which I'll talk about a little bit more in the demo. And then we can also do the same thing when we're creating a new contract inside of that project. It creates a Clarity file and a unit test file. So that's kind of step one, getting started. Then, as I mentioned, we have this tight integration with the IDE. IDE is integrated development environment, if you're not familiar with that term. But VS Code is our tool of choice. And so we have this integration that does all kinds of functionality for while you're working in Clarity contracts. So in this screenshot, you can see right off the bat, you can see the syntax highlighting. So we've got nice coloring that helps you identify what's what in your contract. We've got these red squiggly underlines for errors. If I mouse over one of those, I see the error written out. We've got completion, so auto completion suggestions. As I start to type, it gives me some suggestions for what I might want to type here. Basically all these different things to kind of keep that process of actually writing the Clarity code as smooth as possible while you're inside this editor. Now the piece, so as I mentioned, this is kind of Clarinet talking to VS Code. If you don't want to use VS Code and you are, diehard Emacs fan, it is possible to use Clarinet. It supports the LSP, which is a kind of a standard for language servers. So if you'd like to, you could also use Clarinet to interact with other editors, but that might require a little work. So step three. So now I've written my contract and I want to play with it a little bit. So we also provide a REPL, which if you're not familiar with that term, it's a read, evaluate, print loop. And that allows you to basically write out an expression in Clarity. It gets evaluated, you see the result, and then it loops. So that's read, evaluate, print, and then loop. So inside of this REPL, it's basically this little console that loads in your contracts, and then you can interact with them directly inside that console. So in this screenshot, we have a billboard example, which I'll get to in the demo, but we can actually call the functions from that contract in this REPL, and we see any events that got emitted. So here we have a stacks transfer event, and then in green here we see the result from that. So this is very convenient for like interactive development. What kind of while you're building, you want to test things out and play with it as you go. This is where we use the REPL. Step 4 is the static analysis. This is, so as you're writing your code, or when you think you're done writing your code, you can run Clarinet check, and you'll see any errors or warnings that are provided by the tool. So these are going to be the same things that we saw in that first screenshot inside the IDE. Sometimes you might want to do it from a step in the on the command line, and you might want to integrate this into your into some of your tooling by using the command line interface. But same types of errors. So it detects all kinds of syntax errors. It analyzes your clarity for correctness and things. And then we also have some static analysis to detect common vulnerability scenarios. So this warning here at the bottom, it says use of potentially unchecked data. That's from something that Clarinet provides called the check checker, which basically just, I'll show this in the demo as well, but the high level overview is that it looks for a common error situation in your code and prints you a quick little warning for that. Next step is unit testing. So as I briefly mentioned in that first kind of skeleton code section, it generates unit test framework for you. And what Clarinet provides is this TypeScript package that lets you interact with your contract, call functions from that, and then verify what the output is that you're expecting. So, and then it has this nice little, so I run Clarinet test, we see this nice clean output that shows this test passed, this test passed, this test passed. And you can integrate this into your continuous integration environment or whatever you need to make sure that as you're making changes to your contract, you're not breaking anything. Again, in the demo, I'll dig into some details about what those unit tests look like. Then the other kind of testing is integration testing. So when we write smart contracts, we're not just interacting with them via Clarity. There's going to be usually some sort of front end that has to interact with your smart contract. And so to do that, we need to actually run this thing on a real network so that we can interact with it using the API, which is also another tool provided by Hiro. And what this integration testing is, so using Clarinet Integrate, we actually spin up a local network of Bitcoin node, a Stacks node, and then all of the other, the API and the Explorer that you would need to interact with that. So this uses Docker to basically test in a realistic environment. So instead of just everything being simulated like it was in our unit tests or in the REPL, in this case, it's actually running on a real platform, a real blockchain. And again, I'm going to show some more details about that in the demo. But all this testing that we just did, we probably going to run into some bugs. So we also have this integrated debugger inside of VS Code or on the command line if you prefer. But that allows you to set breakpoints in your code, step through line by line, look at the different errors, or sorry, the different values as you go along, print things out. Very helpful for figuring out where something went wrong when one of your tests does detect an error. Apologize, I know I'm going through things very quickly, but basically my goal here is to kind of show you all the features so you know what to look for. And then as you get going, you can always reach out to me and the rest of the team at Hiro to ask questions. And then kind of the last step is once you're ready, you've tested, you've debugged, the last step would be then actually publishing your contract to the network. So Clarinet can also help with that. We have something called deployment plans, which I'll talk about more in the demo as well. But it's kind of a one-step process to launch your contract out onto the network and have it be ready to be interacting with users. That works for both the testnet or mainnet. Okay, so that was my quick overview, but now I want to dig in a little bit deeper into those things in the demo. And the demo is going to be like more interactive, so feel free to interrupt this part with questions if you like. Okay, so you can see my VS Code window now? Yep, okay. So I started off here just showing the Clarity extension. So when you're in VS Code, if you click on extensions here and search for Clarity and then find the one from Hiro Systems, you can find our extension. Go ahead and install that, and then you'll have those features that I talked about. And I have started off here with, I created a new project called Billboard, just like in the screenshots I was showing. So here we have the basic folder structure is here. No contracts or tests yet. But now I'm going to add a contract. Oh, actually, first let me I'm going to show the tree. So this is kind of what our directory structure looks like. Then let's go into our Billboard directory and create a new contract. Is this? Let me move this. I'm not sure if you guys can see this zoom in thing, but I'm going to move it over here. Okay. So we're going to create a new contract called Billboard. And then let's run tree again. So here we now have a billboard.clar. So here's our clarity file, and here's our unit test that created. So if I come up here, refresh, I can now see this clarity file. And you see this just generated some comments. So in clarity, these semicolons start a comment. This is kind of just a suggestion for what you might want your format of your file to look like. But for the purposes of this demo, I'm going to go ahead and just paste some code into here.
Hey, Bryce, real quick, can you zoom in on the VS Code?
Sure. How's that? Is that better?
Looks good to me.
Okay.
Great.
Yeah, thanks for that. All right, so let's see. So what this demo is going to do, it's called Billboard because it basically just has a string that theoretically you could create a front end for that shows up on a website or something. And then there's a price set. So you see these two data variables, Billboard message and price. And what we want to do is to allow users to overwrite whatever this string is in the message if they pay the current price. And each time a message gets written, then the price increments. So pretty simple contract. You can imagine, I'm not going to show a front end for it in this demo, but you can imagine what the front end would look like. Basically just has this billboard, lets you offer to pay to overwrite the message there. And then the price just keeps going up. So we have just three functions here, two read-only functions to read the price and the message, and one public function to set the message. And we can see that this does a stacks transfer. So this is paying for your message, getting the current price, and then we're setting the message and setting the price. So as we look at this, you can see the syntax highlighting. Everything is nice and easy to look at. One interesting thing that might be confusing here is this comment. So I mentioned briefly the check checker. So this is kind of a magic comment that the check checker uses. So if I delete this comment, you'll see that we get a warning here, use of potentially unchecked data. And then this blue note up here says that this is the source of the untrusted input. So essentially what that's doing is in software of any kind, one of the most common sources of vulnerabilities is when you're taking input from an untrusted user and then doing something with it without like paying any attention to what it is. So what the check checker looks at any place where you're using input from a user. So this is a public function. So this input could come from anyone. It checks for that type of input. And when you use that to make an irreversible change to some data, so in this case, we're writing to billboard message, which is a data variable, then it's going to give us that warning. And there's various ways that you can check these things, but for this case, it's just a string that we're writing. We don't actually want to do any checking for it. I suppose we could like write a check for profanity or something like that. But in this case, we just want to use this magic comment to tell the check checker that that we're going to allow unchecked data for the next expression. So that's a quick example of what the check checker does for us. So I'm going to skip over the rest of the details of the contract so that we can get back into what the tools can do for us. But let's go ahead and run this in the console. So let's bring up our console. Oh, I must have changed something here. Okay, so there we go. I detected an error. Oops. Okay, let's try that again. Internet console. Okay, so in our console here, we see that our contract got loaded. We have these 3 functions, and now we can interact with it. So let's start off. I'm gonna copy and paste just to avoid any typos as I'm demoing here. But we can start off. We can call our various functions from the contract, so we can get the message, we can get the price, and then we can set the message. So in this environment, we don't have to worry about fees or anything like that. So in the devnet.toml file, we are setting up various accounts that get used inside of this simulated environment, and each of these wallets starts off with a very large balance of STX. So so we can feel free to spend those here. So if I call Billboard set message and I say Hiro loves developers, so we see that got emitted. We have the stack transfer event emitted, and then we get a return value of the new price. And if I call get message again, we see our new message. If I call get price again, we'll see that the price got incremented as well. So again, this kind of interface is super convenient for kind of during the development process. Allows you to interact with it, figure out what's wrong before you quite are ready to run your unit tests, but after you've gotten something which feels like you're heading towards a working contract. Okay, let's leave the console and let's go to our unit tests. So I'm going to ignore those errors for right now. I'm going to go ahead. Oops. Sorry, I just hit the wrong button there. 1 second. Okay, good. Came right back in here. So let's come back to our unit test, and I'm going to copy and paste something into here, save some time. Okay, so let's look at an example here. So each of these blocks is one unit test. We can provide a name that's a very nice descriptive name about what's going on, and this is what shows up in the output from the command line. And essentially what we're doing is we interact with the blockchain. We have a function to call read-only functions or to mine a block and have contract calls inside of that block. Let's look at this one because this is more interesting. So here inside this contract call, we call our contract billboard, we call the function set message, and we pass a value to it. We have functions to generate all the proper types for the clarity objects. And then after that block is mined, we can check the receipts of the block to verify that it has the type of results that we're expecting from whatever we ran inside that block. So here I'm looking for 1 receipt in the block. I'm checking the height of the block. In this case, it's height 2. And then in receipt 0, which is going to be the results from this one contract call, I'm checking the result and I'm checking that it has an OK result. And then here I call the read-only function to get message, and I verify that it does have the string that I expect it to have. So then we come here and we can run clarinet test, and it'll run these tests. We see 2 of them passed, but 1 of them failed. And the one that says ensure the price increments by 10 failed. So let's figure out what went wrong there. I'll come back to our contract. Okay, so I see that I was incrementing by 20 here. So I fixed that. So now it's incrementing by 10. If I run clarinet test again, and we've got our 3 passing tests. So this is really convenient for writing out the test to make sure your contract is doing exactly what you need it to do, making sure you don't break things as you make changes. And we also have some tools, which I won't get into right now, but to check the coverage of your code. So you can actually verify that your tests have touched all the different lines of your contract code. Okay, so let's see. Next, I'm going to jump into the let's jump into the debugger. So let's say we had this bug, and I couldn't figure out why my unit test was failing, right? So if I come over here to run and debug, create a new launch.json file. So this is basically just telling VS Code what we want to debug. We're going to debug set message. This is just a name. And then the key part is to define what expression we want to debug. So we're going to do a contract call for our one and only contract billboard. We're going to call set message, and we're going to pass it a string. Debug this. Okay, so then I save that file, and I see I have call set message here in my dropdown. Now I can run this, and what's actually happening behind the scenes. Let me make this smaller. So it has started executing the set message. So we did a contract call to set message, and we can see like the values of things over here on the left-hand side. So the parameter message was passed in, debug this. That's what I passed in there. We could set a breakpoint, but just by clicking over here in the left, they call this the gutter, left gutter, and then I can press continue, and it'll continue executing until it hits this breakpoint. As we go along, we see new variables over here. So we have a let expression here, which creates two local variables, and we can see their values. We can actually execute expressions down here in the debug console. So I can say like new price minus current price. And so there, this is kind of finding that pretend bug that I had. So I say, oh, this is 20, it should have been 10. And then I can come back and say, oh, okay, here's where I went wrong right here. But essentially, so this contract is pretty simple, but if you had functions calling other functions, you can dig down into the functions. So this is step in and step out. So this would go down into another function. This one's pretty simple, so there's not too much to show off here. But if we let it finish, then we'll see the events that got emitted and the return value from that debug session. So again, debugger, super helpful for finding those issues. And then the last key thing that I want to show is the integration testing. So if we run clarinet integrate, this does have some prerequisites like having Docker installed and set up on your machine. Because basically each of these services is running in a Docker node on my local machine. And it's essentially running the complete network. So it's running a Bitcoin network of one node, it's running a Stacks network of one node, and then it's running an API that talks to that Stacks node, and it's running an Explorer and for an Explorer for both Stacks and Bitcoin. So let's see. So here, let me make this a little bit bigger. We see as soon as the Stacks node boots up. Okay, so now our contract got deployed here in the first block. Or sorry, our contract was in the mempool. Now it's deployed in the second block. I can go back and forth to look at the details of each of these blocks. And if I'm gonna go ahead and copy this contract name and open up the Explorer, switch back to Chrome. So if you've looked at Hiro's Explorer for the mainnet, it basically allows you to look at blocks that have executed, transactions that are confirmed or are pending. This is essentially the exact same thing, except for running on your local network based on this local Stacks API. So inside of here, I can see my billboard contract got deployed right here. I can come to the sandbox, and let me copy this again. So if I come to the sandbox, I can actually interact with my contract in this sandbox. So if I paste that contract here, I can see the functions, and I can call get function and see the current, or sorry, get message. I can see the current results. So this is super helpful for interacting with your contract actually in the real world. And this does have the API. So if I had a front end built for this project, I can actually connect with this pretend network and fully test both my front end and my back end all together. Turns out to be very, very helpful. And then let's see, anything else I want to show in here. Oh, the last thing I'll show. So just Control C to kind of tear down that network. Deployments. So if I want to use Clarinet to deploy to testnet or to mainnet, we have what's called deployment plans. So deployments generate testnet. Actually, before I do that, I want to copy. So this is using these TOML files. And by default for mainnet and testnet, there's no mnemonic specified there for any accounts. So I'm going to copy one from DevNet into testnet so that we have a real wallet to use here. And then if I run deployments generate, we'll see that it generated a file. And this is a very simple deployment for this example project because there's just one contract. But if you dig into this, as you get into more and more complex projects, you can publish multiple contracts in series. You can interact with them. You can call different. You can like actually perform transactions on the different contracts in between deploying, all kinds of different things. So there's a lot of flexibility there that you can dig into as you get into that complexity. All right, so that wraps up my quick summary of Clarinet. Let me switch back to my slides here. And I'm going to talk just a little bit about some educational resources. So Hiro has a very active blog that has lots of great tutorials and information about what you can do with our tools, what's coming in the future, what just got released. So definitely check out our blog. There's a couple of links in these slides, which I think we'll share if we haven't already. And then our YouTube channel also has lots of helpful tutorials and how-tos. This one in particular, I believe this cohort is just getting started. Is that right?
Yep, that's right.
Yeah. Okay. So if you're very new to any development environments in general, you might want to check out these Clarity development setup videos. There's one for Mac and one for Windows that kind of help from the start, like from knowing nothing at all. And then you can kind of follow through a bunch of different tutorials that we have there from myself and from my colleagues at Hiro. Just to take a quick glance at some of the other products that I didn't mention today. So you have kind of the two products that are for both developers and users. That's the wallet and the Explorer, which we talked about the Explorer and the wallet. I think you're probably familiar with already. And then the three that are just for developers are Clarinet and VS Code, Stacks.js, which is very helpful for building your front ends for interacting with your contracts. And then the API, basically Stacks.js is a wrapper around the API in most instances, but you can also interact directly with the API for different use cases to grab information from the blockchain. I also want to do a quick demo of the Stacks.js starters. So as you get past your smart contracts and you're ready to build those front ends, then this tool that one of my colleagues developed is super helpful. So basically what I'm going to do here is I'm going to select a framework. So I'm going to select Vue in this case. I'm going to choose a couple of things, what features I want. I want to connect with my wallet, and I want to call and read from Clarity Smart Contracts. And then I can either generate this project locally. It'll show me the command line instructions to do that, or I can play with it in a sandbox right in the browser. So we're going to do that just to show you a quick demo of what happens here. But you see we've got a whole bunch of code that got generated over here on the left. And then, okay, this should be loading up over here on the right. Okay, so here we go. So we've got a Vue page running over here. We've got a button to connect our wallet. It works. I can click it. I can connect my wallet here. And then I can interact with a contract. So in this example, there's this voting on which fruit you like better. And that will interact with your wallet. And you can, the key here is not necessarily this page itself, but if you come over here to look at the source, look at your components, you can actually, so the connecting your wallet, a lot of times it's just copying and pasting that code exactly. And then the interacting with smart contracts, this is where the really interesting stuff happens. So here, there's a contract published at this address. So from this principal with this contract name, and we're calling the vote function, passing it arguments and passing it post conditions, which you can read more about in one of our blog posts. And then, yeah, so it just provides a really, really helpful kind of getting started with the front end side of it. So now we've got the getting started for both the back end and front end. And that about wraps up what I wanted to cover here. I'm happy to stay for a while and answer questions, but also I wanted to kind of direct your attention to an effort that we have going on right now to try to learn more about what our users are interested in, what is helpful about our products, what you're struggling with. So if you're interested, after you've used our tools for a bit, if you wouldn't mind helping us out by taking the survey, we would love to hear your feedback on everything that we have. And the first, I think the first some number of people get a complimentary NFT for being one of the respondents to the survey. So definitely check it out when you have a chance. All right, so questions? Also, I know there might not be immediate questions. I am pretty active on Discord, so feel free to ping me in the Clarinet channel or the Clarity channel or the Dev General channel, and I try to help answer questions there as often as I can.
Thank you, Bryce. That was awesome.
Great.
Um,
Thanks.
I do see a question here in the chat.
Oh yeah,
I believe was directed towards the Stacks.js demo. It says, what's the difference between make contract call and open contract call?
Let's see. I'm trying to find that question. So Stacks.js is not something I'm looking at every day. So this is going to be not definitely the correct answer, but I'm going to try. So essentially there's actually, maybe I won't answer that specific question since I'm not positive of the answer, but let me just kind of give a little bit of a higher level overview. So there are a few different things that you might want to do with Stacks.js. The first is calling read-only functions. So a read-only function doesn't actually have to broadcast a transaction to the network. It just pings a node and then gets a result right away because it's just reading data from the existing blockchain. So that's kind of the simplest way to interact with Stacks.js, to interact with the network. The next way is actually calling a contract. So that requires a transaction. And so there's a multi-step process there where first you generate the transaction and then you actually submit the transaction into the mempool. So I have a feeling that those two functions are related to that multi-step process, but I'm not sure off the top of my head. So I won't say for sure. If anybody else on the call knows the answer, feel free to jump in. But basically, when you're calling a contract, you generate the transaction, then you publish the transaction into the mempool, and then essentially you have to just wait for that transaction to get processed. So you know, the blocks are generated on average every 10 minutes. So it could be up to 10 minutes. It could be, you know, they're not always 10 minutes. It could be an hour. So you need to have something in your interface to at some point later in time, check on the results of that transaction once it's actually been committed to a block. And then for the details, I'd say ask a question on Discord or refer to the documentation for Stacks.js. They're pretty good. I'm going to try and go through these questions. If anybody typed a question earlier and wants to just speak it out loud now, I'm sorry, I wasn't paying attention to the chat at all. So feel free to just ask them now. Oh, it looks like Elena and Hugo were helping answer questions as we went. Thanks, guys.
Bryce, I have a question.
Mm-hmm.
As far as I understood, Hiro is the company that is creating tools for developers on Stacks.
That's right.
Is Hiro the only company doing this, or I mean, is it are there other companies, or are people actually allowed to create developer tools for Stacks?
Sure. Yeah. So good question. So yes, definitely anyone is allowed. So everything on the Stacks blockchain is open source. It's a completely decentralized chain, but also even within Hiro, all of our products are open sourced as well. So we're trying to provide the best functionality for developers, but there's nothing preventing anyone else from developing their own tools. So there is there's another JavaScript library for interacting with the API. There's another tool for helping with writing Clarity contracts that's out there. So yeah, anyone is welcome to contribute anything at all to the community here.
But for the moment, Hiro is the only one. Is that correct? For
a tool like Clarinet, Hiro, as far as I know, Hiro is the only one building something like that. Yeah.
Okay. Great. Thank you.
I can answer a little bit more to that question in particular. There's teams like MicroStacks, for example, is another JavaScript library. And then there are other teams doing kind of explorer-like projects like dashboards and analytics. Yeah, I can get you guys a full list if that would be helpful. But Bryce is correct in terms of development environments that have all the features that Clarinet has. I think Clarinet is in a league of its own. There's also clarity.tools, which is browser-based, but it's not as, I don't believe it lets you kind of deploy to mainnet and stuff like that.
All right. Thank you, Elena.
Bryce, I had a question. So I'm a little OCD, so when things don't always look the same, it's sort of jarring for me. So when you open up Clarinet contract, the old videos I see, and even a slide you had, shows deployer as part of the address. But the newer versions that went away, is that like gone forever, or is that just a something that's
in which part are you talking about? In here?
Right there, but not when you open it up, but on a slide that you had early in your presentation.
Oh, okay.
Under address, it would say deployer.
Oh, okay.
Is that like a permanent change, or is that something that like there back? You there. So yeah. Under the address, it has an additional field of the wallet or deployer.
Oh, okay. So yes. So what that's doing, so that is just kind of some information to help you out. So these names are coming from the devnet.toml file. Get rid of my. So this is like deployer, wallet 1, wallet 2. So yeah, these in the console, those are just showing to. I'm sorry.
Can you get them to show up now, or is that a feature that's no longer there?
So I hadn't actually noticed that. I'm not sure if that was an intentional change or not, but I will make a note of that and either fix the slides or put it back. I don't see why it shouldn't be showing here. So thanks for pointing that out. And sorry, I was missing your point initially, but now I get what you're saying.
I also noticed that in the core, in the book, we had with wallet 1 in parentheses, but in the Clarinet itself, when we open it, there are no wallet 1 written beside the addresses. Okay.
Yeah, I think that probably, I don't think there's any reason that was removed from here. And it should be easy to put back. So yeah, that's definitely, I can't think of any reason off the top of my head why not to show that here. So thanks for pointing it out. Oh yeah, I saw this question about re-showing these balances. So thanks for that answer. So if I run get asset maps, get assets maps, then it prints this again. Someone asked in the chat. And this, the one thing that is frustrating to me about this console that we have not resolved yet is that there's no tab completion inside of here. So I have to type this whole command out. That's something that's on my to-do list to improve within here. But as you're building, and I know a lot of people are brand new to development, a lot of people are coming from other environments. So you'll have great insights from like different points of view for us. So any things that you notice as you're using these tools as a newbie, definitely we'd love to hear your feedback of like, oh, I used this other tool before that does this, and was kind of missing it here, or this new thing confused me and could have been made more clear if you did XYZ. That kind of stuff we'd love to hear. On GitHub, submitting new issues is the best place, or if you're not comfortable using GitHub, feel free to just post on Discord.
Bryce, I have a quick question. I noticed in the billboard.clar for your STX transfer, you have that in an unwrap as opposed to a try. And I'm just curious if that's purely for the throw value or if there's another reason to use unwrap.
Yeah, I think that would be the main reason. So with unwrap, I can control what happens in the error case. Versus, so if I use try, then it would throw the error that STX transfer throws, which I think is like a U2 or something like that if you have an insufficient balance. And just by using unwrap, then I have the option to include my error here. And I think so. Actually, the newest kind of standard that I like is changing this a little bit to put the error inside here, and then changing this down here. I should have updated this example, but by kind of having one place in your contract where you specify all the constants, all the errors as constants, it makes it really easy to figure out what went wrong when you try to call a contract and it fails. So that's my preferred method, but both would work fine.
Cool. Yeah, thank you.
Yeah.
And
Bryce,
this slide brings up another question. Do you have any naming convention, like some of the variables are, I guess, kebab case, and then your constant was the snake case with all caps or something?
Right.
I mean,
there are some kind of community standards right now. There's actually a SIP. If maybe Hugo or Elena, if you could find that SIP where there's some suggestions about standardizing that. But yeah, so there's kind of just been some ad hoc standards that have arisen from a bunch of different developers. This kebab case for function names and variable names is kind of standard. Like you said, the capitalized snake case for the constants. There's a really good list. I don't remember all the different ones off the top of my head, but there's a list of like coding standards that is it's in the SIP repository. It doesn't, so if you haven't heard the term SIP yet, that's a stacks improvement proposal. And it provides a way for community members to suggest changes to the network. And something like that, I don't know if it necessarily needs to be a SIP because it doesn't actually require any changes in the network or even in the tools or anything for people to use it. But it's useful just to have some kind of standard that says this is what the default should be for most developers to make it easy to interact with other contracts. And then if it was a kind of a ratified standard, then inside of Clarinet, we could have tools to check to make sure that you're following that. Yeah, so Elena, I don't know what the number is, but there's a I'm not sure if it's a discussion or a PR. I can find it.
Sourcing? And cost? No.
No.
Yeah.
Let's see. No, what is it?
I'm trying to find it as well.
Okay. Oh, I'm not signed in on this one. Anyway, I can find the link and post it into the Clarity U channel later. But yeah, that definitely would be helpful. And I believe the Clarity book follows those standards that are specified in there. Oh, here we go, Hugo. Yes, Hugo found it. Let me open that up over here. Thanks, Hugo. So yeah, we've got some naming conventions, constants, local and persistent variables, maps. Yeah, this has some nice discussions about different things. So WoBuddy is one of the main contributors to this. WoBuddy is from the CityCoins team, and LNow is very active in the community. And yeah, LNow was the one that started this. So these are, I've looked through these and I think I agree with all of these things. I might have commented one here. Yeah. So there's no tools that I know of that help to enforce this or anything, but it is something that is starting to kind of standardize informally.
What I also noticed as a newbie is that some functions have a question mark at the end and some not. What is the reason of this?
So that was one of my first questions when I was learning Clarity as well. And the sad answer is that there initially was some reason that they were trying to follow, but it's not actually consistent. So the idea would be that the question mark, a question mark returns an optional value, and the exclamation point could throw an error. But it turns out that in the initial, like in the first, when Clarity was first released, that wasn't entirely consistent across all of the functions. So now it's more of just a so if I look at stacks transfer, this one can throw an error, but it returns a question mark. And unwrap can throw an error and it has an exclamation point. So I don't know why, at what point it went wrong, but I don't think there's a consistent reasoning for that, unfortunately.
We just have to learn the names, right? Of the
Yeah. So the book, so from the the Clarity documentation on docs.stacks.co, I am constantly opening this page. So docs.stacks.co, come down here to functions. And you can search this using Command K if you're on a Mac. So I could search for like STX transfer. And you can see the inputs. The output here is a response, the signature, the description, and example. So this page is super helpful as you're writing code and trying to remember what the order of the arguments are to a built-in function and things like that. Oh, yes. And as Hugo said, the VS Code extension will autocomplete and help you with that a lot as well.
Oh, great.
Oh, so Greg just said the STX transfer is optional. No, so it's a response, not an optional. I think a lot of the ones that return a response have a question mark, but I think I talked to, I don't remember who it was that I talked to. Maybe it was Marvin about this when I was learning Clarity, and there's definitely some inconsistencies. I don't remember exactly where. Okay, so this one is a question mark and it returns an optional. Whereas this one is a question mark and returns a response. So there's, for whatever reason, they didn't end up being consistent with it. The exclamation point here, I think the exclamation point is one of the ones that consistently, well, I don't know for sure, but the exclamation point means that it will, if it returns the error, if there's an error, then it will actually exit the current control flow. So that's when you see an exclamation point, look out for exiting the control flow and unwinding any changes that happened before that. Will FT transfer city coin? Yes, that would be the kind of thing you would use for that. So FT stands for fungible tokens. So the different city coins, NYC coin or Miami coin, those are defined as standard fungible tokens, and so you can use these transfer methods for them. Actually, sorry, that is not quite correct. So this function would get used inside of the fungible token contract. So like in this little example here, a fungible token called Stackaroo is created, and then you use FT transfer inside of that contract to transfer the functions. But you wouldn't be able to call FT transfer Stackaroo from another contract. You'd have to call some wrapper function that's defined in this Stackaroo contract to interact with it. So, so yeah, I guess the answer to your question then would be no, not exactly. You can't directly call FT transfer to transfer a city coin unless you're inside of that contract. But so there are standards. So there's standards for the fungible tokens and non-fungible tokens that allow the wallets to interact with them in a standard way. So if I were to open my wallet, I just have like a demo wallet installed here. But if I had any fungible tokens here, I could use the send and receive to send those. And by following the standard that's defined in one of the SIPs, it plays nicely with all the different wallets that are available. When can we expect to work after completion of camp? I like that question. Immediately, I hope. So I'd say get right to work. Get right to work before you're even done camp. There's lots of great opportunities right now.
I have a question.
Sure.
So as far as stocks 2.1 being released, which I'm not sure when that would be, what changes do you expect that to have, like, on Clarity?
Sure. So there are a few new functions that are being added into Clarity for Stacks 2.1. So basically Stacks 2.1 includes Clarity 2. So there's kind of two different things there. So Stacks 2.1 is technically just changes to the blockchain itself. But as a part of that, the blockchain is supporting this new version of Clarity, which is Clarity 2. And so there are some new functions. I don't think they're in this list yet, but there's a good article that describes the different changes in Clarity. I found this, I posted this the other day. Does anyone have it handy? Let me see if I can find it real quick. Let's see.
I just shared the blog from the foundation, Bryce. I don't know if that's what you were referring to.
That's a good one. There's one from Mechanism as well. That's a good one. Yeah, this one. So this one is kind of focused specifically on new Clarity functions. I'll post that in the chat too. But so there's this better handling for sponsored transactions. There is an easy way to check whether you're running in mainnet or not. Some functions to be able to convert between buffers and integers, which can be very helpful for different kinds of operations. This is especially useful for trying to decode Bitcoin transactions. And then converting between strings and integers. So you could do this with Clarity 1, but it was really ugly. You had to write some functions and have really large maps to do it. This makes it simple to do that. Some slice handling. I think that so I'm not entirely sure that everything in this article is the latest, but I believe most of it is correct. You can do a stacks transfer with a memo inside of your contract. Lots of different things. So take a look through that, and also that that article from the foundation.
Thank you.
Yep.
Well, looking at this blog post, I'm not sure you guys are the ones to even ask this question, but I was wondering with Stacks 2.1 interactive with the Bitcoin native assets. So does that mean you don't need XBTC anymore? You can just use BTC with Stacks?
So there's nothing directly in the 2.1 changes that enables that to happen. But there are, so basically some of the features that are added make it easier to interact with Bitcoin. And there's several different projects that are working on ways to directly interact with native Bitcoin through Stacks, using Clarity. So it's not a built-in functionality of the network at this point, but there are a couple different solutions in progress to essentially the state the current state, even before 2.1, is that you can read from the Bitcoin network, no problem. And the 2.1, the Clarity 2 functions make it a bit easier to implement that reading and decoding of the Bitcoin transactions. But then there's also a bunch of projects in place to implement some sort of decentralized Bitcoin right implementation, so that I could actually cause actions on the Bitcoin network from my smart contract and not just read things that already happened. So it's an open problem, but there's a lot of interesting work, and it's like one of the big problems that the Stacks community is working on solving right now.
Gotcha. Okay, thank you.
Yep.
All right, everyone. We are coming up on the hour here, and I want to make sure that we're respectful of everyone's time. So if there are additional questions, maybe we can take the conversation in Discord and do some Q&A there as it comes up.
Sounds good.
Awesome.
Thanks, everyone.
Yeah, thank you guys for being here. This was great. This is really helpful.
Awesome.
Thanks,
All right,
Bryce.
good luck.
Thank you.
Thank you.